So actually what I'm going to do as folks are filtering in is to actually put up this slide that gives you the information about how to access the materials for today's tutorial. So you can either, well, I should say first, before you start trying to access these materials, I think it works best if you first open a browser and log into your Google account. So like, for instance, your Google Drive account. So just log into Google Drive. You will need a Google Drive account in order to sort of follow along with this tutorial actively today. So hopefully you already have that. If not, you can try to create one quickly in the next few minutes. And then before accessing the materials, I think it's better if you're already signed into your Google Drive. Once you sign into Google Drive in your browser, then you can click the link, which I think Elaine just shared in the chat. And it's also posted here, or you can use the QR code, which takes you to the same place. And so this should take you to a Google Drive folder that has 4 files in it that we'll be using today. One of the files is actually these slides. So it should be a PDF of this same slide deck that you'll be seeing. And that might be helpful just if you want to continue clicking on links that are included in the slides as I'm going through the material today. The other few things are things will be sort of materials that we'll be using for the tutorial, the more active tutorial parts, and I'll explain those shortly. But you can go ahead and start, for those who are already here, you can go ahead and start trying to access these materials while we wait a few minutes for other folks to filter in. And please post in the chat if for some reason you're not able to access these things.
All right, I think we can go ahead and get started. So thank you everybody for joining us today for today's edition of CAFÉ University. I'm Elaine Bertolini. I'm one of the program managers for CAFÉ, and I'm here to introduce Dr. Rachel Nethery, who is part of our CAFÉ capacity building team and an assistant professor of biostatistics at the Harvard T.H. Chan School of Public Health. So I'm going to turn it over to her for this webinar on wrangling and processing historical weather data for climate and health studies.
Thanks, Elaine. So yeah, I think I am going to continue to put up this slide so that you guys can work on getting access to the materials for the webinar, while I simultaneously give a little plug for CAFÉ University webinars more generally. I think for a lot of folks, given the attendance that we have today, I think probably for a lot of you, this is your first CAFÉ University webinar. So welcome to those who haven't been to one before. Just want to give you a little bit more context about what these things are. These CAFÉ University webinars are part of the CAFÉ NIH Research Coordinating Center for Climate and Health, which I am a part of, and Elaine. So within that CAFÉ Research Coordinating Center, I co-lead the capacity building function, and I'm responsible for creating climate and health education and training resources, including these monthly CAFÉ University webinars. So these webinars, again, are held every month. They're meant to be educational in nature, and they cover various climate and health topics presented sometimes by CAFÉ internal folks like myself. So today's session happens to be led by me, one of our internal CAFÉ folks, but a lot of times, if not most of the time, these CAFÉ University webinars will be led by sort of external visiting experts and lecturers from across the world. The content for these webinars varies really widely, from things like what you're going to see today, like data science related tutorials, to research translation trainings, and other lectures on advanced methods and substantive topics within climate and health. Recordings of all of the webinars are then made freely available afterwards on the CAFÉ YouTube site. So if you have to drop off for part of this webinar, you can catch up with the rest of it when it's posted, hopefully in the next few days on our YouTube site. So that's my plug for CAFÉ University webinars. I will tell you a little bit more about the next few webinars that we have coming up at the end of the session today. So hopefully by now, everybody's had a chance to access the Google Drive with the materials. Again, you should be seeing something like this with a Google Drive folder with 4 files in it. You don't necessarily have to download all of these to your machine yet. Some of them will actually be using in the browser. So for now, if you could just keep this open in this Google Drive open in the background, we're going to be returning to these materials shortly after I give a little intro. So recently, there's been this explosion of papers looking at associations between climate exposures and health outcomes. And so in these studies, unfortunately, we typically, as researchers, don't have the ability to sort of hitch a monitor to every person in the study to precisely measure each individual's exact weather and climate exposure as they're going throughout their days. So in the absence of this kind of personalized weather and climate exposure data, what researchers typically do is to link people's health data that they collect with historic ambient climate or weather data that's sort of collected by monitors and similar technologies. And they link those historic ambient climate records with individuals in their study based on, for instance, people's location of residence. And so this is a really commonly used approach for what I'm calling climate epidemiology studies today. And these studies have now moved far beyond just the standard environmental epi type journals and have been appearing recently, as you see in lots of high profile clinical and science journals. So I'm assuming that you're here because you're wanting to do something along the lines of what these climate epidemiology studies do. And primarily that you're here in order to get information about how to get a hold of those ambient climate data to link in with your health data. And so our objectives of this webinar today are going to be to first just discuss the historic weather and climate data that are available primarily in Google Earth Engine. Google Earth Engine is one of the major hosts of weather and climate, historic weather and climate data from where teams from all across the world sort of submit their data to be hosted on Google Earth Engine. So there's tons of data resources. We'll talk more about those shortly. And then we're going to walk through the steps for integrating Google Earth Engine climate data into your epidemiologic studies. So we'll go through how to scrape the climate data from the GEE API, which can be quite a big learning curve. So we're hoping to walk through that step by step. And in particular, how to get sort of how to scrape data that are restricted to particular spatial areas, timeframes, and climate variables. Then we'll learn how to aggregate these climate data to standard health study geographies that you might be using, how to visualize the data, so map it, and then how to merge it with health data so you can actually do your investigations. So the main piece of background that I'm assuming folks have going into this webinar is familiarity with R and RStudio. So that includes understanding basic syntax in R, different types of objects in R, and basic functions in base R, and also it's helpful, but not strictly required to know a little bit about the syntax around plotting using ggplot2. I'm also going to be assuming that you have either R or RStudio or both already installed in your own machine on your own machine, so that you have it installed locally here or can access it actively during our tutorial. Familiarity with basic spatial data concepts like shape files and rasters, I think will definitely be helpful for folks to get the most out of this webinar, but it's not strictly required as a priori knowledge. So if you are somebody who has no familiarity with basic spatial data concepts, don't jump ship yet. I think I'm going to try to give enough background so that you're able to at least follow along. You might not become an expert in these topics from this particular webinar, but hopefully I'll give enough context that you can follow along. And then I'm going to assume that folks have no prior experience whatsoever with Google Earth Engine data using the Google Earth Engine API. If you do have that kind of experience, this webinar is probably going to be a little bit painfully slow for you. So don't need any experience with Google Earth Engine, but again, you will need a Google account for this, to follow along actively with this tutorial. So if you don't have that, you can, still watch the steps, but you won't be able to actively follow along for now. So let's jump into some background on historic weather and climate data that we're going to be trying to get our hands on during this webinar. So if you're not super steeped in climate and health research, when you start to think about historic weather and climate data and what it might look like, you might first assume that we'd be directly using weather data that's collected at monitoring stations. So of course we have weather monitoring stations all across the globe. And in many cases, for instance, they're located at airports. But the downside of using these monitor station-based weather data for climate epidemiology studies is that they're sparsely located over space, and they leave a lot of spatial gaps where we haven't measured, where these stations haven't measured anything. So that means that for some individuals in any given health study, they're likely to be far away from a monitoring station. And so in these cases, we can still try to assign exposure to climate or meteorological variables to individuals based on, for instance, the measurements at their nearest monitor. But that approach could be very error prone, depending again on how far people are from monitors and how spatially variable the weather variables of interest are. So instead of the monitoring station approach, the gold standard, I think, from what I understand today in climate and health studies, is to use climate reanalysis data. So I've pulled here the description of climate reanalysis data from Copernicus, which is one of the biggest producers of these reanalysis data, and the producer of the data set that we'll be working with today in our tutorial. And so basically they say that these climate reanalysis data basically just combine the actual ground monitoring observations, so the observed data from those monitoring stations that we've been talking about, they combine those with output from these fancy atmospheric models, and then in some sophisticated procedure to combine these two different sources of data. And then the product of that sophisticated combination of the monitor data and the atmospheric model output is basically that they are able to produce measures of many different climate variables estimated at high spatial resolution, by which I mean they're able to estimate the values of these climate measures over a dense grid of points across space, which fills basically the spatial gaps that are the main limitation of the monitor data. So now we have climate variables measured across this sort of dense grid of points across space, which hopefully can give us more accurate local climate exposure measures to link in with our health data. These climate reanalysis data also are nice because they offer sort of consistency over time. So they usually have consistent daily high spatial resolution measures of these climate variables stretching over decades, usually for most of these products. And this avoids one of the major complications with actually implementing the monitor data only approach, which is that monitors can come and go offline over time. And so that complicates the sort of exposure assignment when you're working with the monitor only data. So these avoid that because you have consistent data basically every day, every consecutive day over long periods of time. This climate reanalysis approach also usually gives some kind of comparability across countries or regions where their monitoring procedures might differ, but these reanalysis data should allow for some comparability in the climate measures that you get across areas. So again, I think these climate reanalysis data are really like the gold standard for measuring climate exposures in health studies today. I'm just going to make a quick note here before we move forward that Google Earth Engine is known for having tons of satellite data available as well. So they have these climate reanalysis products, but they also host tons of different satellite data. We unfortunately won't be talking about raw satellite data at all today. There are many more complications and much more processing required with raw satellite data, and we won't have time to delve into all those today. So just to be clear, satellite data are a totally different thing than these climate reanalysis data, and you won't be able to apply the same procedures we learned today directly to satellite data. However, I think we're thinking about a satellite data tutorial as maybe a future CAFÉ University webinar, so stay tuned. So suppose that I've convinced you to use climate reanalysis data in your studies. Why should we get our climate reanalysis data from Google Earth Engine? So the main perk of Google Earth Engine is that it hosts most of the popular climate reanalysis data sets. So most of the ones that are commonly used in research are housed there. So you can basically learn sort of one set of procedures to access GEE. And that can give you, it's really powerful because it gives you access then to all of these different popular climate data sets. They're also typically pretty frequently updated with more like real-time data. And then Google Earth Engine is also free for nonprofit academic research use. We'll talk more about that shortly. And so Google Earth Engine also has a nice data catalog where you can get a sense of the types of data sets that are available there. So if you use the link in the slides, it links you to the Google Earth Engine data catalog. And so you can see very quickly that they have tons of different types of data, climate and weather data, satellite imagery data, which we won't touch today, and then lots of geophysical data like land cover and night light data and things like that. So focusing on our interest today, the climate and weather data, let's just click on the climate data tab to see some examples of the types of climate data that are available. So you start seeing when you click into this climate data section, you quickly start seeing some climate reanalysis products. And so the climate reanalysis product that we're going to work with today is actually going to be this ERA5 data, which is a popular global project. So let's just click into that to see what it looks like in the data catalog. So ERA5 is the name of this reanalysis product. And ERA5 produces lots of different data sets at different temporal aggregations, but we'll be using the daily data. So this is telling us that we're using the ERA5 daily data. So when you click into this, you can see some basic information about the data, the dates for which it's available. So the ERA5 data are nice because they basically have daily data for the whole globe, for a whole bunch of different climate variables, which we'll see in a second, over a multi-decade period from the late 1970s to roughly present. You can also see who the data set provider is. And if you scroll down a bit, you can see a more detailed description of the data, as well as if you click on this bands tab, you can directly see all the different climate variables that are contained in this data set. So you can see in this particular data set, for every day over this whole period in the whole world, we have estimates of air temperature, the mean daily temperature, the minimum daily temperature, maximum daily temperature, dew point, total precipitation over the day, surface pressure, wind direction, things like that. So this is a pretty standard set of climate variables to be provided with a reanalysis data set. You'll also notice, and we'll come back to this a little later, that, you know, if you were wanting to use this data set for your research, there are terms of use and some citations that you should pay attention to so that you can give proper credit to the data set creators if you end up using any of these GE data sets in your publications. So notice on this page that this seems to be a sort of first step towards accessing these data, but note that you don't see any download button, right? So if you come to this page and you haven't worked with Earth Engine data before, you would probably be looking for that download button so you can download this data. Not there, there isn't a download button. So let's come back to that point in a moment. Just noting that there are tons of other popular climate data sets available on GEE. I know we have a big US contingent usually at these webinars. So some of the more popular US specific climate data sets are the PRISM data and GridMet data, which are also available on GEE. So now let's talk about, again, assuming that you're on board with using climate reanalysis data and that you're on board with getting it from Google Earth Engine, how can you actually go about accessing the data? So remember, we just said when we go into the data catalog, there's no download button. That's because data from GEE are only accessible through, to my knowledge, basically two modes, neither of which involves any point and click options. So there's not an option to go in and click download somewhere. The way that you access these data is through either the online code editor built within Google Earth Engine, which requires using JavaScript, which I think most of our sort of community of climate and health researchers are not familiar with. Or the second option is to access the data through a Python API. So these are two options. Sorry?
No, just quick question, or just quick point that there's a couple questions coming up. So would you like to address those now, or would you like for people to hold on to their questions until the end?
I just have like a couple of more slides before like a natural break point. So I can address them at that break point in just like 2 slides, unless it's something urgent.
All right, so everyone, thank you for your questions that are popping up. So we will get to those shortly. So just hold on to those questions.
Yeah, I'll get to them in just a sec. So, these data are only available through these 2 options. And so I think at least for me, the most intimidating step for sort of trying to get my hands on Google Earth Engine data was figuring out how to even set things up to get access to this data. So in this tutorial, we'll first walk through the steps to set up access to the Google Earth Engine API. The API is where we pull the data, the Google Earth Engine data from. And then we're going to show an example of how to scrape and export the Google Earth Engine data using the Python API. So one of the two options for accessing the data. We'll use the Python API, but we're going to show an example that should be relevant to those with little or no Python experience. So don't panic if you don't have any Python experience, basically like myself. For this tutorial, you won't need to know any Python. You won't need to have Python installed on your computer. We're going to use Python through a browser-based Python engine provided by Google Colab. We'll talk more about that in a second. I also want to flag the note at the bottom of this slide, which is that there is, in fact, an R package. We know R is a more popular software among our sort of community of researchers. There is an R package called RGEE that can, in principle, interface with Python. So the package sort of first calls Python, and then Python uses the API to pull data from Google Earth Engine. However, I've personally found, and I think many other folks who have tried this would agree, it can be extremely difficult to install this RGEE package on many machines. For instance, when I tried to install it, my partner, who's more of a computer scientist, and I tried for about 5 hours. I think it took us about 5 hours to get the package set up on my machine, with tons of bugs and tons of research. So it can be really difficult to install on various different types of machines. I've also been reading some online forums which suggest that the creators of this package have concerns about whether it can be maintained in the long term. So here to sort of create a tutorial and a solution that's sustainable over time, and to avoid having to deal with trying to troubleshoot installation of the RGE package on many different operating systems, we're just going to avoid the RGE package altogether. But don't panic if you don't have any Python experience. That's totally fine. You don't need any Python experience to follow along today. So who is this tutorial actually intended for then? It's specifically going to be geared towards non-Python users who want to scrape data, weather and climate data primarily, from Google Earth Engine, but want to basically do the minimum possible in Python. They just want to use Python to do that necessary sort of data scraping piece, and then export the data from Python to do further processing and analysis of the data in another software. Usually we know with our community of researchers, they primarily use R. So that's who this tutorial is really going to be geared towards. If you are on this call and you're an experienced Python user, I will just note that there are lots of instructions and examples of how to use the Google Earth Engine API that are provided in the Google Earth Engine documentation. So if you're an experienced Python user, this webinar might help you sort of get up and running with GEE if you haven't used it before. But I think it won't be as mission critical to your understanding how to use GEE as for other folks who are not Python users, because for Python users, there should be already a good amount of documentation available that should resonate with you. So why do we pick this audience? So we recently did a survey of our CAFÉ community of practice, so our climate change and health research community. And we found that most members of our community primarily use R for coding, and relatively few use Python. So only about 20% of people who responded to the survey reported ever using Python. And so the issue here becomes that one of the biggest hosts of climate data, Google Earth Engine, is only accessible through Python or JavaScript, which I assume even fewer folks would use JavaScript than Python. So it's only available effectively through Python, but our climate and health researchers tend to not use Python. And what I found personally is that there's quite a steep learning curve and very little documentation for learning how to scrape Google Earth Engine data for those who, like myself, aren't super familiar or comfortable with Python or Java. So we want to provide this very practical solution for folks who want to use Python basically as little as possible, but need to use it to do the data scraping and exporting so that you can then use the data in within other softwares that you're more comfortable with. Okay, I think this is the natural point to take some questions, so I can pull up the questions in the chat real quick.
Great. We have one hand up, so I can, there we go. If you have your hand up, you can go ahead and ask your question. You should be able to unmute at this point. And if you are not, or if you don't feel comfortable, you can feel free to put your questions in the chat and we can answer them that way.
Yeah, go ahead, Francesca, if you can unmute yourself. Looks like you're still on mute.
Okay, pressed on accident, not a problem.
Oh, okay. No worries. I do it all the time. No worries. So then maybe the only other question I see is Pat's question in the chat, asking for the reanalysis data, I assume, do we have measures of uncertainty at each location? And I believe the answer to that is it depends on the product. I think most products, most of the reanalysis products do at least claim that they generate some uncertainties. But whether they post them along with their sort of estimates is, I think, varies by product. So it's a good question. I didn't actually check for today if the data set that we're going to be using in the example has associated uncertainties or not. My thought is no. It's a good question, an important question. So,
and we have one more question in the chat that just came in, which
okay.
is, does GEE provide any weather data with hourly resolution?
I believe there are some, but I believe a lot of those products that provide the really high temporal resolution are often sort of restricted to smaller spatial areas. So today we'll be like focusing on an example that uses like the global climate reanalysis products. And those only provide daily, I believe that's the minimum temporal resolution they provide. You may be able to find hourly products for like particular countries or regions. In theory, these climate reanalysis, like the sort of modeling of the climate reanalysis data does actually output sub-daily, I don't know about hourly always, but sub-daily estimates, but a lot of times those don't end up getting posted online, probably because of like the massive size of those data. But you could always, if you're interested in those for a particular product in those higher temporal resolution data, you could always reach out to the data creators and see if there's a way they can make those available to you. Good questions. Okay, so now let's jump into the more like tutorial part of the session. So again, for me, like the most intimidating part of getting started with Earth Engine data was really just the setup of like, how do I even get started getting access and accessing the API. So it's going to be a good amount of like data science jargon going on in this presentation, and I don't want people to get lost, so I'm going to try to interweave some little snippets here and there to try to explain some of the jargon for folks who may not be data scientists, experienced data scientists. So I've been talking a lot about this Google Earth Engine API. So what is an API? API is just an acronym that stands for Application Programming Interface. And so APIs are used all over the place for lots of different things. But for our purposes here, you can think of APIs as just an interface program that allows two other softwares to talk to one another and exchange data. So for our particular application here, the Google Earth Engine API is going to allow Python and Google Earth Engine to talk to one another, and specifically will allow Google Earth Engine to pass data into Python. So for our purposes, you can sort of think about the API that way. So it's just this interface software that allows Google Earth Engine to pass the data into Python. And the thing about APIs is that usually you need to use code rather than point and click methods to extract data via an API. And the downside of this, of course, is that it tends to make the data a little bit less accessible to folks who don't have coding background. The upside of needing to use code is that it makes your pipelines more reproducible. So you can always go back and see exactly what data you pulled using your code. So again, there's going to be several steps to setting up access to the API and then actually accessing it. And I don't want people to get sort of overwhelmed by like all the different steps and why we're doing them. So just to sort of ground everybody, I wanted to give you first a high-level overview of the approach. So the first thing we're going to do is to register for access to the API. And that access will be linked to your Google account. So you'll, again, need a Google account to register for access to the API. So to get your Google account approved to access the data. And then we're going to be running Python code, which will run through our browsers using Google Colab, which is again a browser-based online Python engine run by Google. So you don't need to have Python installed on your personal machine or know anything about Python. But we'll be using this browser-based Python implementation to scrape data from the Earth Engine API and then export the data to Google Drive and then from there you can use the data as you want. So first step that we're going to sort of walk through in the tutorial is to just register for the Earth Engine API using your Google account. So again, before you start, please open your browser, and if you haven't already, log into your Google account. So you can just log in through like Google Drive or Gmail or whatever. So please already be logged in before you start this process. And then once you're logged in, you can either use the QR code or the link here to get to the sort of starter page for the registration. And so just a note that on the next slide, I actually sort of walk through each of the steps of the registration just to have those for future reference. But I think here it would be good if we actually walk through these like in real time together. So I'm also going to register, even though I'm already registered. I'll register another project with Google Earth Engines just so we can all walk through the process together. So when you click that link, and Elaine, if you could, it might be worth posting that link in the chat, just in case people didn't get a chance to grab it. So when you click the registration link, you should see this landing page. And so from here, you're going to say that you want to register a non-commercial or commercial cloud project. So the Google Earth Engine is basically going to be accessing the Google Cloud. And so that's what that's referring to. So click forward on that. And then it's going to ask you how you want to use Earth Engine. So again, Google Earth Engine is free to use if you're using it for nonprofit research use, education use, media use. If you're using it for one of those purposes, then of course you would click this unpaid usage. If on the other hand, you are planning to use Google Earth Engine for some kind of business or for-profit endeavor, then you would probably need to first talk with your organization to sort of have an agreement with Earth Engine about, you know, payment and all of that stuff, because you do have to pay if you're using it for commercial purposes. For us, I'm going to assume almost everybody, if not everybody, is using it for nonprofit or research purposes. So click unpaid usage, your project type. For me, it's academic research, but you can pick the one of these options that's relevant to you. If you work for a nonprofit or whatever, you can click that. Doesn't matter. And then click next. And then let's say that we want to create a new Google Cloud project. This is going to be sort of our Google Earth Engine project. I don't know why this organization dropdown is here. It doesn't have anything. So at least for me. So you can just leave that blank or whatever. And then you'll need to here input a unique project ID that you keep track of. And so this is gonna sort of link your Google account with your Earth Engine project. So here you should put in some name, some project ID name that's memorable to you. I already have a project ID with this name, so just for today, I'll just do EE CAFÉ as my project ID name. But just remember this because we'll need it later when we're actually accessing the API. And you can just leave this as is and click continue to summary. I'm not sure if my internet is failing me. Oh, no, here we go. So just a recap of what you just put in. If everything looks okay, then you can say confirm on this page. And now you have a registered Google Earth Engine project that's associated with your Google account. And so this is where you should land once you have successfully set up the Earth Engine access and project. See, there's some stuff going on in the chat. Just want to make sure things okay. Right, so if you haven't already accepted the terms of service, you probably have to do that. I may have already done that in the past, so that may be why I didn't get asked. But if you haven't already accepted the cloud terms of service, you probably have to do that before proceeding. So this should be what you see if you've successfully set up your access and project. And this is the online Earth Engine JavaScript editor that you're actually seeing here. We are not going to mess around with JavaScript since I think it would be quite unfamiliar for most folks doing climate and health research. And I think it's better to work from Python. So from here, once you have registered your account, you can actually just click out of this. But again, remember that project ID so that you you'll need to put that in later. I am not sure. I'm just reading in the chat that somebody got an error, a permission denied error when creating the cloud project. I do not know what would cause that. I've never had that happen before. So sorry, I don't know that I'll be able to troubleshoot that in real time. If other folks are having this issue, please write in and let us know, or if anybody knows a workaround, feel free to post it in the chat. So again, these are kind of the steps, a recap of the steps that you can refer back to later if you need to. But now you're all set up and registered, again, with your Google account to access the GEE API. So now remember, if you first just think back to our approach here, we've done step 1 here. We've registered for access to the API. And now we're going to do this, the second step of running Python code using Google Colab to scrape GEE data from the API. Okay, we're getting some useful feedback in the chat about how to troubleshoot some of the errors. So thanks to folks who are chiming in on that. So now let's first just chat a little bit about, just again, because I don't want people's heads to be spinning with all these different terms, Earth Engine, Python, Colab, API. So again, to try to ground ourselves, let's first talk about what Google Colab is, because I imagine it may be unfamiliar to a lot of folks. So Google Colab is basically just a browser-based online Python engine that's supported by Google that allows you to write and execute Python code straight from your browser. And the nice thing about it is that there's very little or no configuration required. So again, you don't need to have Python installed on your own machine. You know, you can easily share code. There's access to GPUs if that's of interest to you. So if you want to see more generally about Google Colab, it's a super handy service. You can click the link here. But for us, why would we want to use Google Colab to get GEE data? Well, recall we have 2 choices for getting the GEE data. We can only access it through Python or Java. And so we're going to try to access it through Python. And I assume that lots of folks working in this space don't have Python installed on their own machine. Even if you are somebody who already has Python installed on your machine, setting up the package to access the Google Earth Engine API can actually still be quite complicated. Google Colab sort of resolves that issue because the Python instance in Google Colab already has the GEE API package installed by default. So you don't need to do basically any setup. You just log into the Google Colab script and then sort of load in the GEE API package. And then you can easily use Google Colab, use Python through Google Colab to scrape data from the API and export it to your Google Drive, and then from there, do whatever you want with it. So let's now go ahead and go back to that Google Drive folder that we shared at the beginning, which has our Google Colab script for our webinar today within it. So going back to the Google Drive folder, again, it should look like this. And your Google Colab script is here. It's this extract rasters file. So giving people a second just to transition over there. And clicking it open. You should see something that looks like this. So note this is actually a markdown file that interweaves sort of text blocks with code chunks, sort of like our markdown for folks who are familiar with that. So we're going to walk through these steps first. First, we're just going to walk through the steps to actually get the API set up in Python. The first thing that I would recommend for you folks, because you all will not actually be able to you will not actually be able to edit my file. So this is a file that I own, and you won't actually be able to go in and edit it. So what I recommend doing before we get started is to go over here to save a copy in Drive and to click that. So go in, File, Save a copy in Drive, and that will save a copy of this same file but that's owned by you in your drive, so that then you can edit it, because you won't be able to actually directly edit my file. So save a copy in Drive. You can do that. And then you'll have to go back to your Google Drive and find that file. And I believe by default, what Google Drive does is it by default creates a collab notebooks folder within your Google Drive and saves it there. So I actually did this process earlier, and it saved a copy of that extract rasters file in my collab notebooks folder. Yes, we will be able to share the recording so that you can, in case you get behind following along in the tutorial, you can come back to it later. So, so once you make a copy of this in your own drive, then open that copy and you should actually be able to edit that copy. You won't need to edit it too much for today's tutorial, but of course, if you're going to use this in the future, you may need to edit it. So let's get started with first just loading in the Google Earth Engine API package, and then authenticating using our Google login info. So telling Python, here's my Google account info that I want to use to interact with the API. So first, we're just gonna basically load the packages. That's what this first little code chunk here does. It just loads the Earth Engine package, the EE package, that's gonna allow us to access the API. So this has already been installed in the background of Python that's running in the background here. All we need to do is tell Python to sort of load in this library that we're going to use in our code here. So you can run each chunk of code just by clicking the play button next to it. Just click the play button and you should see a message at the bottom after a few seconds that it's completed. So now we've loaded the Earth Engine Python package that's going to allow us to access the API. But now what we need to do is tell Python what our Google account information is so that it knows what Google account information to feed into the Earth Engine API so that it knows that we're approved to access the data. So this code chunk here is going to use sort of two different commands to do that. First, this EE authenticate function is going to basically take your Google Drive or your Google account information. It's going to actually open a new window to have you put in that information. And then here is, I think, the only thing that you'll need to change in this script. You also want to tell Python what your Earth Engine project is called. Remember, we created that project ID when we were setting up our Earth Engine account. And I called mine, I think, EE CAFÉ. So here you'll need to change this to whatever you called your project when you registered your Google account with the Earth Engine API. Question in the chat is, can someone else access my project? No, not unless you set the share settings so that they can access it. So, okay, once you've inserted your project name in here, which I'm actually going to use my old project name. I could use either one. Once you've inserted your own project name that you put in, then can run this piece of code, and you'll get this pop-up message that wants to allow this notebook to access your Google credentials so that it knows your Google account information to pass into the API. So you have to say allow in order to move forward. Then you'll get this other pop-up window that asks you what Google account is linked, basically, which of your Google accounts, if you have more than one, is linked with the Google Earth Engine API. So which account did you register with? On this next slide, sign into collaboratory runtimes. You'll need to click continue. And then Google is basically just saying Google Colab wants to access your account information, which again, it has to do to pass that into the Earth Engine. So you have to say continue here. And then you should be good to go. So that has run successfully. And now we're basically set up to access the Earth Engine API in Python. Now, just to do a quick test to make sure that the setup of your API went properly, let's just do like a little toy example here where we pull in global elevation data and then print the elevation of Mount Everest. So that's this little chunk of code here. You don't need to understand what's going on in the chunk of code. So this is just a little test to make sure everything's working right. So what this code should do is go in, pull the elevation file from Google Earth Engine API, and then extract the information about the elevation of Mount Everest and print it. And so if you click this, hopefully it runs successfully and it prints out below the Mount Everest elevation. It's 8,729 meters. So if that runs properly, then you should have the API access set up properly. So now, assuming that went well, let's go back quickly to talk about how we're actually going to do the wrangling of the data using the API. So first, before we start trying to wrangle data, we need to know what format the data are in. So most of the climate reanalysis data products store their data as what are called raster files, or sometimes these are called image files. And so rasters are just objects that are composed of lots of different pixels, or you can think about them as grid cells that are organized into rows and columns. From a data science perspective, I often like to think about these rasters as sort of like matrices. And so we have this set of pixels organized into rows and columns. That's our raster file. And then each pixel contains a value of the variable of interest. In our case, a climate variable that corresponds to the spatial area that's covered by the raster pixel or the raster grid. And so then these pixel values can be mapped to color scales and then visualized. So you'll often see rasters visualized as something like this. And then if you zoom in here, it's kind of hard to tell, but if you zoom in on a little spot in the raster, you can easily see that this is just a bunch of pixels organized into rows and columns, each of which has a value that is then mapped to a color for visualization. I will note that different climate reanalysis data sets are provided at different resolutions, meaning that the rasters can have sort of higher or lower density of pixels, where high density of pixels, more pixels in a small area, corresponds to sort of higher spatial resolution, typically to more accuracy, and lower density of pixels corresponds to lower spatial resolution, and therefore typically less accurate information for capturing exposure in our health studies. But in general, the rasters containing the climate reanalysis data should sort of have this form. And so going back to that ERA5 data set that we're going to work with in this tutorial, remember we're working with the ERA5 daily aggregates. And you can actually see here the image that's visualized on this page in the data catalog is actually just a visualization of the raster for a given day. Remember, it's covering the whole globe. You can kind of see the country outlines in the visualized raster. So we're going to focus on this ERA5 data example because it's global and it is available for a really long time period. And so that makes sort of this a very generalizable example that anyone can kind of working in any region of the world could kind of relate to and possibly use. That doesn't necessarily mean that we're sort of by default recommending the ERA5 data, that everyone should be using these by default for every analysis. In practice, the right data set for your analysis, of course, depends on your context. So remember, the GE data catalog provides descriptions and citations for each data set, and you should really read those and understand the data before deciding which one to use in your context, as well as possibly reading existing literature to see which products, which climate products are sort of considered to be the best quality for the region that you're working in. And when they're available, reanalysis products that are actually more local or more tailored to your area of interest might have benefits over using these global products like ERA. They might be more accurate for your region of interest, and they also, in many cases, have higher spatial resolution, which tends to allow you to better capture local climate variability. So these are some considerations when selecting the data set that you're going to use. At a minimum, of course, your selected reanalysis data set should cover the spatial area and the study period that's of interest, for your health study, and it should contain the measures of the climate variables that you need. So the next step before we move to actually scraping these data is to identify a couple of pieces of information about them from the data catalog. So first, we need to identify what is called the Earth Engine snippet, which is provided at the top of the data catalog entry for any given data set. You'll see this Earth Engine snippet here. And the string within here is the Earth Engine snippet that we'll need when we call the API to tell it which data set that we want. So this is essentially an identifier that the API will recognize. So we can use that to tell it which data set we want to extract. So you'll need to take this string, and it's already in the Google Colab script, so you don't actually need to copy paste it here. But in general, you'll need to grab this string to use in your code for whatever data set corresponding to whatever data set you're using. And then remember, we have a whole bunch of different climate variables available in ERA5 and most climate reanalysis data sets. So we need to pick which one we want to extract. Here we have all these different ones, but let's just suppose for the sake of illustration that our interest is in this first one, the daily average air temperature at 2 meters height, roughly, the height that people feel. So let's suppose that this is our variable of interest, and we'll just need to, again, sort of copy paste, keep track of the name of this variable here that we will pass to our code. So we need that EE snippet for our data set, and we need the variable name for our climate variable of interest. So now let's return to that Google Colab script, and we're going to use these to then pull the data. So in this example, again, this is just a toy example. Let's suppose that we want to scrape the ERA5 temperature data, the variable that we just identified. And let's suppose that we want it for California, the state of California in the US, for the period July to August 2019. So suppose California is the study period for our health study, and our time period of interest is July and August of 2019. So we want to grab those data, and then we want to export them to Google Drive. So before we get started with grabbing the data, first, please go back to your Google Drive and create a folder called EE_exports. Doesn't necessarily have to be called that, but it will make things easier since that's what I've called it in the code. So go to your Google Drive, and over here you can create a new folder by clicking new folder here, and then call it EE_exports. And click create. I'm going to click cancel because I already have that folder here. So you'll just have an empty folder, but this is where we're going to tell Python to export the raster files to. So before we get started with that exporting, scraping and exporting, just first want to note that the ERA5 rasters cover the whole globe and this multi-decade period. And if all we're interested in is data for California and for this like 2-month period, there's no need for us to scrape all of the ERA5 data, which would be huge, and it would take an unnecessary amount of time and storage space. So a key part of figuring out how to scrape these data is figuring out how to specify the dates and the spatial area of interest in our data request. So first we're going to focus on that, then we'll do the data request. So first we want to get the spatial boundaries of our sort of study area that we're going to input into our data request so that, again, we don't have to extract the whole global data, which would be huge and take a long time. To restrict our data that we get from GEE to California, we have to provide the boundaries, a shapefile with the boundaries of California in our call to the GEE API. So first we have to get that shapefile, this file that just contains the boundary of California. And luckily, Earth Engine has most global administrative boundary shape files already sort of loaded in and available within Google Earth Engine. And they call these sets of boundary shapefiles feature collections, quote unquote. So the different types of boundaries that they have already sort of pre-available in Google Earth Engine are, country boundaries, world region boundaries, US state and county boundaries. And if for some reason the boundaries of the spatial area that's of interest to you isn't available already in one of these feature collections, you can also provide manually provide coordinates like lat-long coordinates for like your spatial area of interest. But here we just want data from California. And so we can call the US state boundary feature collection using EE feature collection, and then this string that tells it that we want the US states. And here in the comments below, I've sort of showed you how you might obtain other types of boundaries. So if, for instance, instead you wanted US county boundaries, you would use this string within the EE feature collection call. If you wanted world country boundaries, you could use this string, and so on. So you can see a lot of examples here of different types of boundaries that you might want for your like real data example. But here we're going to just focus on getting the state boundary file. And then this is going to include all the US states, the boundaries for all the US states. And then in this line of code below, we're going to tell it that we only want to actually keep the boundaries for California. So we're telling it to take this states object that we created above and filter it to only include California. And then in this last piece of code in this chunk, we're just saving just the boundaries for California. So this is saving it as just like a spatial boundary object. So if you click run on this, it runs super quickly. So now we have this geom object that contains the spatial boundaries of California that we're going to then pass into our call to Google Earth Engine to tell it that we want to restrict the data that we're asking for to California, the bounds of California. We also need to specify the date range for our data request so that we don't end up getting data all the way back for a multi-decade period if we only need 2 months of data. And so here we can do that just by plugging in the start date and end dates into these objects. And if you put the dates in this format, year-month-day, Python will sort of automatically recognize these strings as date objects. So you could, of course, put in, if you were interested in other dates, you could substitute those appropriate start and end dates in these strings here. So now we're almost ready to call the API to scrape the data. So a little bit of context before we do that is that GEE calls the set of raster files for a given data source. So the set of raster files, for instance, associated with the ERA5 data, it calls that a quote unquote image collection. And in Python, you use this function ee.imageCollection to grab image collections from the API. And within the call to that function, that ee.imageCollection function, is where we'll put in that EE snippet information to tell the API which data set we want. And we'll also put in the climate variable name that we identified to tell it which climate measure is of interest. So here I've just saved as objects the EE snippet. So this is that string, that EE snippet string that we identified in the data catalog, and the name of the climate variable of interest that we also pulled from the data catalog. So now we have all the pieces that we need to scrape this data set. And so this code here actually scrapes the data set. And so what we're doing here is we're going to save the scraped data in this object called IC, which is an abbreviation for image collection, but you could use anything, you could call it anything you want. We're going to call the EE image collection function where we input the EE snippet, which we've saved up here as in this IC name object. So we tell it which image collection we want. Then in this next line of code, we tell it which variable we want. So we're saying within this image collection that we want, select the variable that we've specified up here. And then we're saying only return data to us that's within the date range of interest. So that's between this start date and end date that we specified. And only return data that's within the spatial bounds of interest, which of course, remember, the spatial bounds of interest are contained in this geom object. That's giving us the boundaries of California. So this is telling us it's telling the API to restrict to the date range and restrict to the spatial area of interest. And then this last line of code here is just sort of showing you what the object looks like. This image collection object looks like once you've pulled it. So run that real quick. And you can see here that this display IC is sort of like the summary command in R, where it's telling you sort of the high level information about this image collection object that it scraped. This object, it says, is an image collection that contains 61 elements. So it's basically saying each element of the image collection is the raster file containing the information on our climate variable of interest, mean air temperature, for a given day. So we have 61 elements because we have an element or a raster file corresponding to each day during this 61-day period that we specified. So just glancing at this gives us some confirmation that this did what we wanted. And so now that image collection with, again, those daily raster files containing mean temperature information for California are stored here in this IC object. Okay, so now we've done the hard part. And the very last part is actually, even though the code looks a little daunting, it's actually really simple to run. So now what we want to do is tell Python to export this data that we've scraped to your own personal Google Drive. And remember, I told you to make that EE exports folder, which is where these we're going to tell Python to store the exported files in this exports folder. So in the code here in this chunk, we first defined a general function that can take as input any image collection. And then what it will do is write all the images within that image collection to raster files that are stored in your Google Drive. And raster files can be stored in numerous different formats, but we're going to store them in this GeoTIFF file format, which is a standard file format for raster data. And so this function is generalizable. It can be used to export any image collection. And you don't even need to, unless you want to sort of amend it or manipulate it somehow, you don't even need to fully understand what's going on in this function. But basically what it's doing is it's taking your image collection as input. It's looping through the image collection to get relevant information about, to extract each one of the individual images, get some relevant information about it, and then using this batch export to drive function, which is a built-in function within the Earth Engine package, to export each one of the daily raster images to your Google Drive. And so this function takes as inputs 4 different arguments. The first argument that it takes as input is the image collection that you actually want to export. The second one is some description, which will be used in the file name for the, it'll be used in the file name for the exported data. Then it takes as input the folder within your Google Drive that you want to store it in. And finally, it takes a final argument that is just, again, telling it the spatial area that you want to restrict your files to. So just like another layer of telling Python, we really only want the California data. So this part here is all just the function that you don't need to mess with at all. If you're not familiar with Python, all you'll need to do basically is supply inputs to the function in this call to the function here. So we're calling our function. We called it export to drive. So we're calling our function, and then we're inputting our image collection that we created below, which we called IC as the first argument. Then we have this description argument where we're going to basically just putting in temp to remind ourselves that this is temperature data that we're exporting, and that temp string will be included in the file names in Google Drive. We're telling it the folder that we want to save in, which is that EE exports file that we created. And this final argument, we should just again provide the California, the boundary files to again assure that we're getting data, raster files that are restricted to just the area of interest. So all you need to do is now click run on this code chunk. And this code chunk actually is going to take a second to run. It will take even longer if you choose larger spatial areas for your data request or longer time periods. So we just chose this relatively short time period to focus on so that it won't take hours for our request to run during this tutorial. And so as it's executing, it should be starting to save some of the raster files to your Google Drive. So as it's running, let's look over here in the Google Drive, and you're starting to see some of the files come up in your Google Drive folder. And it completed for me in about 40 seconds. So not too long. You don't immediately see, it takes a second for all of the files to get sort of ported over to Google Drive. So they sort of appear slowly, but they should be coming. And note that, each one of the files is going to be a raster, where the file name starts with temp, that description that we gave of what the data are, into our export to drive function. And then it's going to tell you the date corresponding to the particular raster. So if we give this a second, all of the raster files for the whole time period that we requested should pop up here. And then once they're in your Google Drive, you can do whatever you want with them. So now you have these rasters. They're extracted, and assuming that many folks like me would prefer to move to another software now and do further processing and analyses, you can simply download these files, download this folder, and then import these files into another software that you prefer. So let's give that a second to finish downloading. I'll note quickly that a limitation of this Google Colab plus Google Drive approach is that if you're a super user, if you're like running very large jobs that require sort of many images or rasters, or they require super large like global images or rasters, you could run into storage or computing time limits on the Google services. So if that's the case, if you're using this like really heavily to scrape tons of data, you might run into these limits. I haven't in the past, but if you're a really heavy user, you could. In that case, you will likely need to actually go through the process of installing Python on your own machine, setting up the EE Python package on your own machine, which can be a little bit complicated. And then once you have those on your own machine, you can run the code and extract the images and save them all locally hopefully without running into those limits on computing time or storage. So again, that would only be relevant, I think, for really large scale users. And so I realize we're kind of tight on time here, and I suspected it might be difficult to get through to this next part of sort of further processing of these climate data. So was hoping to talk with you about mapping, aggregating, and linking these data once you've extracted them. And was planning to sort of do those pieces in R. So I'm assuming that most folks here, again, are more familiar with R per our CAFÉ data survey, and would prefer now to switch to R. Now that you have these climate data raster files, you'd prefer to switch to R to further process them and link them with health data. If not, if you actually prefer Python, then you can just continue working in Python. You can also use other softwares other than R. Since you have these files downloaded, you can load them into whatever software is comfortable for you. I don't think we'll have time to go into all of the data processing and linkage, given that we only have about 5 minutes left in the session. But I did want to note that you can walk through this piece yourself. I've provided in the I've provided in the folder that we shared, I've provided this climate data processing R file. And so you can download this to your own machine. And yep, so you can download it, save it, and then you can open it in your own local R instance. And while I don't think we'll have time to go through everything, just want to quickly show you what these files kind of look like in R and how you might load them in. And then the rest of the tutorial, I think folks can go through on their own for more advanced stuff. So first thing I'm going to do is, hopefully everything's loaded into the exports file now. Maybe not quite everything yet, but I'm going to go ahead and download it. So I'm going to download this Earth Engine exports folder from Google Drive onto my own machine so that I have these files available to me locally. So I'm going to save it here. Just saving that folder on my own machine. Oops. It saves as a zipped folder, so you can just, on most machines, just double click it to open it up, and it's got all of your raster files here. So just to give you a quick sense of how you might use these, let me load these in and start to use these in R. First, you'll need several packages. For this part, I don't think you have to actively follow along, especially if you don't already have these packages installed. It may take some time to install them. But first, you just install some spatial packages, some standard spatial packages to deal with rasters and shape files. And then I've just set the working directory to the folder where I saved the the raster files from Google Drive. And so here, I'm going to use the raster function within the raster package to load in these raster files. So I'm going to just loop through and load in all of the raster files and save them into a list in R, so a list object. So this piece of code is going to load them in to a list. And so that worked. And so just to plot one of them, so you kind of can confirm that things look right. Let's just plot the first raster in the list, which is the one from July 1st, 2019, the first date of the period that we requested data for. So let's first just plot that to make sure it looks like what we would expect. So you can see this raster file looks like it has the shape of California, so that's good. The temperature by default is, I think, measured in kelvins. So that's what you're seeing on the scale over here. If those numbers look unfamiliar as temperatures, so you'll have to convert to degrees Celsius or Fahrenheit if that's what you prefer. I show how to do that later on in this script. You can also pull county boundaries or other boundary shape files in the same way that we could get all different kinds of boundary files in Python and Google Earth Engine. Those are easily available in R as well. I've provided a little bit of context for how to get your hands on those here. But for us, let's suppose that we're interested in aggregating these data to the county level for California. So we want to get county level temperature data for each day during the study period. So to do that, we can simply load in the California county boundary file, which is easily available in a standard R package. And we can quickly plot it to make sure it looks right. And then these next few pieces, which I won't have time to go through, but I encourage you to go through on your own, can help you to figure out how to actually take the raster files that have your temperature data on those grids, remember, or in those pixels, and aggregate them to the county level. So aggregate them across these county boundaries, as counties are a commonly used geography for health data. So that's a common task you might want to do. So this shows you how to do that. And then how to map the resulting county level temperature data to get some pretty maps, and merge in with a synthetic health data set. So won't have time to go through that, those last pieces today, but hopefully, since again, I'm assuming folks here are more comfortable with R, hopefully you could take this R script that I've provided to you and sort of follow along these steps on your own to do these final pieces of data processing with the climate data. So I think now I should wrap up quickly. Again, I've got some links here for other resources if you want to learn more, including the Google Earth Engine documentation, if you want to become a more sort of advanced user, do more advanced techniques. Also a bunch of different free online resources for delving into spatial data processing in R. There's tons of good books, free online books out there to learn those kinds of techniques if you want to learn more about that. The examples that I show in my R script are pretty simplistic. There's a lot more sophisticated things you can do, and recommend checking out these books for more info on that. And again, I just want to mention that if you use climate data from Google Earth Engine, just make sure to cite and acknowledge the data creators for your data product appropriately. Just quickly before we wrap up, I also want to plug next month's CAFÉ University webinar. So the August webinar is going to be led by Francesca Dominici, one of our fantastic CAFÉ PIs. He's going to be talking about how to write a strong specific aims page for NIH grants. So really invaluable information coming from her, very successful grant writer. We also want to hear from you what topics you'd like to see in future CAFÉ University webinars, and you can use the link in these slides to get to a form where you can input suggestions for future CAFÉ University topics. And in general, it'd be great if you wanted to keep up with all of our activities in the CAFÉ Research Coordinating Center. You can do that on our website. And now I think, I don't know how much time we have left on this webinar. I can try to take questions if there are any in the chat, or if anybody has anything and we have time for questions. Thank you for the kind words in the chat. Feel free to reach out to us if you have further questions. Again, the recording of this webinar will be available on our YouTube site sometime in the next few days, hopefully. No questions. Thanks again for the kind words in the chat. Hope to see you at next month's CAFÉ University webinar to learn how to write a specific aims page. Thank you, everyone.